like and leave a heart, please.
There we go. Hello. Hello, hello, hello. This is a way to keep your viewership live. Nothing like this is what you would say bad client retention.
Okay, now we see it.
David is getting the technical difficulty out of the way early on this one. Thank you, Jessica. I love you so much.
Is that a different
Okay.
microphone?
Yeah, let's try
Okay,
this.
let's try that one.
Oh,
All
I like
right.
those little magnets.
Oh, they say it's working. Hello, yay, yay, yay.
We can hear him.
now. Okay.
All right, let's try this again. Can you guys hear me now?
Sorry,
When I
just
It's
go
okay.
ahead and click
the
it.
new
That's fine.
microphone
All right.
back
Get rid of that
into
a little
thing.
bit. Don't worry about
How about that? How about now?
Fun stuff.
All right.
Yeah.
Check 1, 2, 3. Hello. Can you hear me?
Okay, I see see.
How about
yours.
this?
Hello, 1, 2, 3, ABC, 1, 2, 3.
I do not see. I only see one.
ABC 1, 2, 3. Oh, check it now. I don't know if these new.
Yeah, now I see yours.
Okay,
So
Mhm.
the new microphones don't work with it.
okay.
Okay.
I won't buy one of those.
So we just have to read the name of it on the air.
Yeah, yeah. What is this? What is it? What brand is this? These are the new ones.
Yeah.
Power device.
Yeah. I was just
Power
about to order
device?
something,
Well,
'cause I
well,
like
there we
those
go.
magnets.
Yeah, those. All right.
Okay.
I like these.
What did Keith say?
It says its performance are interpreted in
Yeah. Yeah.
All right.
Typical of the Vidor Locksmith show. Technical difficulties. Yeah. Well, it's like the oil field. You know, not everything's going to go right, and you just got to kind of bounce back from it. I mean, that and the rest of life. You know, it's not just oil field. All right. So, yeah, let's say hi to some people. Jessica, what did Jessica say? David, you are now on mute? Is that what she said? You are loud. You're not as loud now. Oh, you're just scrolling all the way through these. What was Jessica saying?
I don't see Jessica.
It's right under Keith's thing. Jessica Patton.
Oh, David, you are not as loud now.
Oh,
Okay.
well, text mom and tell her
Yeah.
what to do with mine. Or you just keep commenting, and then that'll increase the algorithm stuff as far as getting everything there. All right. So Terry Nelson says, happy Friday. Good to see you. All good now. Paul McClure tuning in from Aberdeen. Thanks for being here. I see John DeWart has commented. Paul Moore, you're on track, David. Thanks for being here. Christian Face says, unplugged is better. Yeah. Baggio, I can't. You'll have to click on them there, Mom. So I can. There's too small for me to be able to read, but that's okay. All right, guys. Thanks for all tuning in and helping out with the technical difficulties. It takes an entire oil field community to be able to get this all set up and running correctly. So I appreciate. I really do appreciate the help, you guys. Oh, look, there's Tracy tuning in too. She's like, oh no, I'm not there to help. All right, guys. I don't have a drill bit. Hold on. 5 seconds. And we're back. If you guys want to win a drill bit, we've got an amazing sponsor who helps to be able to help out with the show every week. Our sponsor is Patterson. So if you want to be able to win a drill bit, scroll up. You're going to put the hashtag PTN up there.
Oh, I did that before?
Yes. The top.
Sorry, y'all. Okay.
There we go. So put in hashtag PTN, hashtag PTEN on in the comment section. You guys will get entered in to be able to win a drill bit. I have the other things here. A hat from Patterson. And as well as one of these ice cube things. It has like their little logo on it, and it's a ice cube little thing. So if you like ice cubes, you like personalized ice cubes, we'll get you one of those, the hat, and the drill bit. So put in hashtag PTN, and here is the our word from our sponsor this week. All right, and that was a quick word from our sponsor there at Patterson. Thank you guys so much for being a sponsor of the show. Really do appreciate it. Like I said, hashtag PTEN to be able to get a drill bit, hat, and the ice cube thing. And we'll do the drawing. I don't know. We'll probably do it towards the end of the show. But you guys can keep putting it in as we go along, as well as if you guys have any questions for our guest today, which is Jeff Lasater with Kinetic Upstream. Jeff, thanks for being on the show. Actually, I probably shouldn't shake your hand because we'll probably bump this and then knock it over, and then we'll have more technical difficulties on our hand than we know what to do with. So for those that don't know, Jeff has been on the show once prior.
Yep.
So we're coming back and making a sequel.
Mm-hmm.
Just like the movie industry, you got to go with your greatest hits.
And it takes 4 years.
Yes.
To prepare for a new one.
Yeah. Don't be creative and create anything new. Just keep replaying the old stuff. So if you're curious, go back and watch that episode because we did a lot of just background, but still want to be able to give you a chance to introduce yourself again and a little bit of your background.
Okay. Well, I'm Jeff, and I run I sort of co-run a company called Kinetic Upstream Technology. That is our main product is rotary steerable. We started that back in 2016, 2017. And my history, you guys can go watch the previous one, but my background was NASA, and then got approached by Marvin Gearhart many years ago and said, come over to the dark side. And so Marvin had invested in a couple of guys that had an idea for a new way to steer. This was back in 96, 97. A new way to steer a wellbore, and they were calling it rotary steerable. That was rotarysteerable.com. So it was actually Rotary Steerable Tools Inc. We spent the next 6 or 7 years commercializing that. We sold that to Halliburton in 2005. And then I was there a couple of years and went back to NASA because we were going to the moon, man. It was like, I'm not going to miss this. And then we weren't going to the moon. So,
and now we're going to the moon.
Yeah. So I got an opportunity in between that.
So if you will stay away from the space program, we might actually go to the moon.
Exactly. Yeah. So that's why I'm back in the oil field. Yeah. Anyway, so I came back in, I don't know, 2011, 12 or so. And long story short, we started a new, we thought we would take a shot at the next generation rotary steerable. And so that turned into the contour tool. And there was a company that I actually worked with you at.
For a month?
You were there for a month? That was it?
Yeah.
Man, you make a big impact, David.
1 month. That was it. That's all I could last with Lou.
Wow. Yeah. So we worked on that for 3 or 4 years, patents and trying to find a gap in the market. And then that company got bought. It didn't make sense for the new company to continue with the rotary steerable. And so I acquired all the technology and the IP and all. And that's when we started Kinetic. And that was 2016, 17. And here we are. And that first company, that RST, I often talk about this, had every company I'm a part of has to have some sort of awful thing happen to them, some sort of adversity or whatever. And with RST in, I don't know what it was, like 2000 or whatever, we had a flood. Tropical Storm Allison flooded the office. We had a flood. And then September 11th happened. And then we got flooded again. Yeah. So, and we somehow, whatever doesn't kill you makes you stronger, right? And so we survived that. This time we're thinking, what could happen? What could happen? What could be worse than that? And so soon after we drilled our first test well, which was at Catoosa, And that was like the end of 2019, September, October 2019.
So that was right after that is when we had our interview then, because it was November.
Yeah,
of
I think so.
2019.
Yeah. And of course, you know what happened soon after that? COVID hit and things shut down. And, what else could happen? How could that, what could go wrong? I mean, what could oil go negative? Certainly not. So, so we weathered that storm, and here we are. And so we had our first commercial well in I think it was probably March or April of 2000, and I would say semi-commercial, commercial trial well, and then
What's the definition of commercial?
huh? Oh yeah, what's the definition of commercial? Well, this is George Sutherland's definition.
Yeah.
And I probably said this before, but we do a well and we get paid. That's commercial. And so that was 2020, early 2020. And then soon after that, all of our customers were laying down rigs and nobody was willing to take a chance. I mean, rightfully so. Nobody was willing to take a chance with the new technology. And so that kind of shut us down. That didn't shut us down, but we kind of revectored our company. We pivoted. We started selling tools overseas. That kept us going, and now things have finally picked back up, and so we're back into the early commercial wells now.
All right.
So there you go.
Yeah, guys. So if y'all have any questions for Jeff, please be sure to be able to throw them out there. An absolutely wealth of knowledge when it comes to rotary steerable tools, steering while drilling tools, automated steering system, the whole bunch of acronyms in there. So be sure to be able to throw those out there. So obviously, like you just said, a lot has taken place since the last time we had spoke. What really is big and new for you guys that transpired during that time?
First off, we haven't had any failures. Getting
Not
through.
one.
No. I mean, when somebody asked me, early on, if I could do this new rotary steerable thing, this was 2012 or so, and the first question was, why on earth would I ever want to do that again? Because it is not easy, as many of you out there know. There's nothing easy about rotary steering, but I think the biggest deal for us, so automation is a big deal for us. And we knew that we had to have the right architecture for a low cost, field serviceable, high dog leg, high temperature tool. I mean, we basically created, when we started early in the early days of this particular technology, we started with what I call the impossible spec. It was the impossible spec. It had everything, and you were along for the ride at that point a little bit when we were defining that. And we went out and talked to 30 different directional engineering operator companies, and sort of got the survey on the market, and it was impossible. Everybody wants everything, right?
Yeah.
And for half the price. And so we wrote this spec, and then we said, that's the architecture that we need to get there. And how can we incrementally get there along the way? And so we had to go prove the technology, specifically prove its steering ability, the inane ability for it to steer the well. And then the next step is reliability, right? Because, making it durable enough the first time you run it is certainly a challenge. And so working through all the sustaining engineering on that is what you spend a lot of your time doing with a rotary steerable to get it as reliable as some of the other systems that have been around for a lot longer. But automation is a big one for us. Automation, high temperature, high dog leg, and getting it and making it reliable. Getting through that infant mortality, having those early runs, being able to stomach, and to take the failure. When you have a failure, to be able to turn around fast and solve the customer's problems and be responsive. And I'll tell you what, just being responsive, just answering their phone calls, just having engineers that jump on a problem and solve it in a few days is a huge advantage for us, because I think we've kind of forgotten, the industry has forgotten maybe how to do that service.
Customer service.
Yes,
Wow.
sir.
I've never even heard of that before. It just randomly popped into my head there. I don't know why we would even.
It's a big deal for us. It's a big deal for us, and it's how you differentiate yourself. And if you can't, if we're not here for the customer, then who are we here for? If we can't solve their problems. So when you start something like this, you're not fully automated. You don't have all the software, the firmware. It takes a tremendous amount of resources to develop that, to prove it, to test it. And so we had not proven a lot of that, and so we weren't running it. But now we have, and so we're running more automated algorithms. I think the next step for us is actually geosteering and geosteering automation. So we're actually taking LWD data, we're feeding it back into the tool to actually steer and stay in the zone.
So that's actually something I wanted to be able to bring up to you. So the last time we had a conversation, we talked about was that you guys had a processor, a downhole processor in the tool that you weren't even using at the time.
That's right. Yeah.
But you knew that in the future that you were going to need to have it there. So you planned ahead. So is that what you're talking about? Is that processor now being used?
It's being used a little bit. Yeah, not a lot. But we are starting to put the steering algorithms in there and bolster the processors. One of our brilliant engineers the other day was we asked him, so how much are our processors working? Because sometimes when you're in high temperature wells, you can't run your processors full out. You can't run them at 1,000% their speed or whatever they're supposed to be running at. And so I think the answer was we were running it at 7 or 8% of its processor capability. So there's a lot of headroom still left in the tool and its ability to do processing downhole, and that's a big one for us. I mean, when your data stream is, and people not in the industry, hold on, right, 1 to 2 bits per second. not kilobits per second and not megabits per second. When it's 1 to 2 bits per second, and even screaming speeds like Schlumberger at 12 bits per second. I mean, but when your speeds are that level, you've got to do a lot of processing downhole. And I had an experience. We may have talked about it last time. There was a time when I was an engineer for a thing called the Mars Pathfinder, for the little rover on Mars. And they had a whole group of people that were all about the automation and autonomy. And the big deal there was that you just didn't have a big data pipe, right, between the two. You had to do a lot with very little data. And so that little robot, that little Sojourner robot had to be able to process in its little brain, it had to be able to process the environment and make recommendations on where to go. And then the guys back home on Earth would say, yeah, that's a good path, choose that one or don't choose that one. They would give it guidance, but not certainly couldn't steer it real time. And that's kind of what we have downhole. We have a lot of information downhole. We have a lot of processing capability, but we have to filter that. We have to process it to get the important information to the surface, so that we can make those decisions and let the tool steer on its own.
So as far as doing the processing and doing geosteering downhole, what kind of inputs are you taking in to be able to do that with, and then what kind of boundaries are you setting prior to going downhole?
I could tell you some of it, but I'd have to kill you. But I could beat you up a little bit though. No. It's the stuff that you would think, it's gamma and LWD. Azimuthal gamma, absolutely.
Because that's come along. That's come a long way in the last couple of years, and it's becoming a lot more ubiquitous across the industry. The use of azimuthal gamma.
It's a big one here in the U.S. everybody wants ASCII gamma. So, but being able to make decisions, if you're steering based on that, or you're staying in the, however you choose to stay in the formation, whatever information you're using, there's no reason the tool can't use that, because our tool has a connection link. It's got a little antenna in here, which works really great. It's a short hop, which is a sort of like a radio link between this and the other tool above us, which is called a Drillcom. And Drillcom is just simply a device that plugs into any MWD. I think we've integrated with 12 different MWDs now. So back when we met in 2019, we were an EM only tool. We were talking directly to an EM system. There was no in between. Our little radio communication deal was we only integrated with EM. Now we have something called a Drillcom, which actually plugs into MWD and allows us to use Mud Pulse or whatever the MWD system is using for communication. So because we're on the MWD system and we're on that bus, we can take MWD information as well. So we could get whatever is getting pumped into their system, whether it's a LWD or whether it's inclination, azimuth. Even though we take all that, we've got a complete directional package inside embedded in the tool. But there may be times where you might want to have multiple readings at different points along the drill string.
I mean, more data is always better.
I won't say any more about that. Yeah, but yeah,
sounds
that's
like
right.
something proprietary.
Yeah, maybe. But so all this is a simple steering mechanism that's reliable and can go in wherever the wellbore needs to go. But it's also got this link with the rest of the BHA and all the other instruments behind it, so that it can actually make decisions about where to go.
Can you tell us a little bit about like the automated geosteering? Like is it like just if it hits a certain formation top, then it's gonna steer back down?
It's really early right now,
Yeah.
but that's the idea. Yeah, as it sees as it comes out of the formation, or as it sees the numbers moving, then it actually makes a decision to steer up, down, left, right,
on its own.
to stay on its own, to stay in that formation.
Wow.
Yeah. There was a funny story. A good friend of mine is actually a kind of a software guy had, and that was where they had. I think they actually had a near bit tool that was taking inclination and azimuth right at the bit, and they noticed that it kept going out when they would lose the link. When they would use it had a short hop link, and when they would lose short hop, it turned out that they were actually in the formation. So they were geosteering. So they would steer depending on whether they were basically steering to keep the tool from not communicating. Every time it communicated, they would try to steer back so that it wasn't communicating. So that's, whatever you can use downhole, whatever information you can use downhole to keep it on track is.
The lights are off. But this is good.
It's right.
All right.
That's right.
The lights are on. No, turn it back off.
Yeah.
That feels so weird to even be able to think about. You're like, okay, you got to explain to like your thing's not working. Actually,
that's a good thing.
That's a good thing,
right?
But it's not. Trust me, I can see that being very difficult to describe at the rig and being able to get people on board with. And
I don't think they realized it until it was happening, and then once it was happening, they said, okay, well, just continue to steer so you can't see it. Anytime it goes out, that's good. You're in the formation. So anyway.
All right. Okay. I was just checking to see if we had any other comments in there with it. So one of the other things that we had talked about last time was that you guys had said that y'all had the 10-year plan. And this was kind of based off of the conversation of us. You don't get into the rotary steerable business to just do it for 6 months. You've got to have that long-term trajectory. Right. So you guys started in 2016, you said? So
yeah, we really started. I mean, we really started in, I would say, mid 2017. All the 16 stuff was business formation. What are we going to do? What's our identity? Building that.
Yeah.
Yeah. So
where are you at on your 10-year plan now? And is it going
absolutely perfectly on track, Dave? Yeah. So here, look, I'll say this about that. We're actually doing really well. I'm so excited about our tool and the capability and what we've done and our team and what we've assembled and what we built. I mean, I really didn't know. So I'll say this about that. When you start a company, and this is my second real company to start. I've started some other ones, but they didn't amount to much of anything. But when you start a company, it's really important that you get other people hooked, so that when you can't take it anymore, they're saying, "Hey man, you brought us along, come on, you can't back out on us now." And so that they pull you, right? So we have surrounded ourselves. People sometimes ask me, how is it, running this company, and I don't run it. I don't run it. I mean, I've got a great confidant, George Sutherland, who has, we've pretty much been together for the last 25 years on and off, with companies. And then we very quickly brought in a guy named Gary Altoff, who's a really sharp technical guy I joke and I tell people he's got 100 years of experience. He doesn't quite have 100 years of experience, but having a core team, that I also, I'll say this also, that I'm more of I'm not a J in the Myers-Briggs scale. A J is somebody that can make a decision, black, white, on, off, clear, make a decision right now. I'm a P, which is a perceiving kind of guy. I'm like, now everything's kind of gray, it's a different shade of gray. But I've made a point to surround myself with very opinionated people, right? Very sharp, smart, bright, opinionated people. So they really, we've got the best guys in the business, working for us. I think I added up our experience base, and it was like 400 years or something, and that's like 18 people. It's a lot of experience. So, where are we now? The big picture is that we proved the tool in late 2019, early 2020, that it would work. COVID really hit us for 2 years. And so that was 2 years actually that we went back into a development phase. And then in 2022-ish, early mid 2022, the market started picking up again. And that's when we started getting runs again. And those runs have been, I think we have, today we've drilled about a little over 40 runs, right? And we've got about 60,000 feet, something like that. Don't do the math and divide by whatever, because, some of those are just test runs. Some of those are quick runs. And, admittedly, some of them are, you learn a lesson real fast, about one thing. The thing with rotary steerable is about 1,000 things have to go right, for
and
for
only
the tool
one thing
to work.
can go wrong.
And if one thing goes wrong, it doesn't. So not only do you have to develop the tool and the architecture and all that, but you have to develop the operational system, right? To ensure that you have the quality control every time it goes to the rig, and that you're running it in the right conditions. But we're really pleased. I mean, we're generating, hold on to your shorts, but we're generating, we can do 17 degrees 100 like no problem. You don't want to do 17 degrees 100, okay? But we also,
there might be some people out there that want to.
Yeah, for those that don't know, it's a proportional steering unit, which means that we can vary. We can send a command to the tool, and we vary its deflection or its dog leg, and that's anywhere from 0 up to about 17, 18 degrees 100. and that what that means is that when we pull it back to zero, it drills truly a straight hole. It doesn't have pads that come in and out. It's got an internal mechanism, which is sort of the uniqueness about the tool. It doesn't have things that come in and out. So I don't know if you can see this or not, but okay. So there's a head on the front of this that rotates, and that head is connected to a transmission inside the tool. When I say transmission, don't think like complex, even motorcycle transmission. Don't think that. Think a really simple way to turn two little rotary motors into some complex motion. That's all that is. And so we can steer the head. This is, you maybe see a little mark on the top of this, but right now I've got full deflection in. So as I turn this sideways, you can see that it's wanting to steer, for me, it's wanting to steer to the right. Or I can steer it to the left. Maybe you can see that as well. So now it's steering to the left.
Yeah.
And then here, let's put it in this right tool face here. Now, if I want to go straight ahead, or if I want to go something less than that, I have a device inside here that actually retracts a bearing in and out and up and down a ramp on the end here. So I'm going to pull it all the way back to zero. You see, now it's just perfectly centralized. So the mandrel is spinning, the shaft is spinning constantly, carrying the loads to the drill bit, and it literally is that amount of friction. I mean, it's actually less than that. We have mud lubricated bearings, so there's no high temperature seals, there's no high rotating seals in here. It's all constantly rotating in a mud environment with a really low friction. And so that's what allows us, so that's steering, we'll see, you can see that, that's steering again, and that's straight ahead. And then we can go somewhere in between, or we can go to whatever percentage we want. So we dial in whatever dog leg we want to steer with, and then the tool steers itself. The tool face will essentially, stay on track and steer itself.
So with the processing power, could you potentially then program in the well plan?
Yes.
And then
it's what we call geometric steering. Yeah. So I always thought it was crazy that you've got a geometric well plan, which is an X and Y and Z, pretty much. But yet when we end up steering, we're steering by azimuth and inclination. So you've got to make that transformation. Why can't we have the tool work out downhole what X and Y is? Of course, there's a missing element, and that is depth.
Yes. Got
to have depth.
Yeah.
So, right now we have the ability to send our tool depth downhole, right? We can actually tell it what the depth is. But eventually, maybe there's a way for us to actually.
Oh, so y'all are actively sending the depth component down to the tool?
We can, yes.
Oh.
Yeah. I won't go any further than that.
These are the boundaries, David.
Yeah.
Don't ask me questions inside of these.
Yeah. I mean, this is a ways off. It's not what we're drilling with right now. We're actively watching the tool. We steer it. The great thing, I mean, it's like lazy boy drilling we have something called inclination hold mode that's got like an azimuthal bias that we can put in to keep it on track there. But it's like lazy boy drilling. It really is. And the stress is so much lower than having to, constantly watch it and steer it and make changes. So yeah.
What's been some of the feedback so far?
Oh, the feedback is great. I mean, there was one well not too long ago where we were drilling, and I can't remember all the numbers, but Guillermo, our head of operations, always talks about this because he was actually on the rig at the time. But he was drilling at, I don't know what it was, 400 feet an hour, something like that, and we were flowing at 700 gallons a minute. And we were steering azimuth and inclination like the tool was just doing it on its own. It was just controlling that and just blowing and going. And it was amazing. Nobody had ever seen that before, to be able to actually keep the tool on track, adjust inclination, azimuth, and, as you're steering and you're blowing and going that fast. So that's really good. the ability for, it seems like when you're a new system, you only get picked up and run where the other guys won't work.
Yeah.
And so that's been our case a lot. It's like, well, you get on the rig and they say, well, yeah, well, the other guys, I won't mention any names on this podcast here, but the other guys, we've already had so-and-so rotary steerable and this other rotary steerable, and yeah, they couldn't steer in this formation. And we were able to, because we do have such high overhead. And that's why we put that in there, whether the hole's going over gauge or whether the formation is just not, behaving, or whether it needs more force or whatever it is. We've been able to steer in some areas where others just couldn't. Either they couldn't hold angle on a long tangent, or they couldn't get the dog leg in the curve. So we don't seem to have a problem with that.
So I know, remember you said that y'all sold some tools overseas. How has the market reception been overseas versus here in U.S. land?
Well, it's been very low, actually. It's not the reception. It's been the I guess the ability to or the desire to take the risk to actually run them in those places. I mean, one in particular is the Middle East, and you got to be real careful, right? If you're going to go and run your tools, for instance, in Saudi or wherever, and you're going to get them certified. You've got to be really careful there. So, we may have sold tools into that region, but some of those tools have actually come back because the U.S. is a better proving ground for those tools, which is right. I mean, it's a lot easier for us to put a tool in the hole to see good performance, but maybe we saw some, strange thing happen. So we want to do a diagnostic on the tool. It's a lot easier for us to do that here in our shop, and have it shipped back from the Eagleford or whatever in a couple of hours back in our shop, service the tool, turn it around and send it back out, than it is to do that, in Oman or wherever you happen to be overseas. So we did sell some tools, and those tools, but some of those tools are actually back here on behalf of that company, right? To get the track record and to get the history and to get the proof in the pudding, so to speak, before they go over and go into that certification.
So as far as being the leader of the company and getting this project out there, what are the key things that you're looking for after each run?
Well, certainly customer acceptance, right? That's everything for us. But we're looking for, I'm a very technical guy, right? So I'm looking for wear. I'm looking for, how well did I hold the well on track? I think that's another one in terms of technology that is, a lot of, I think some of the rotary steerables have some issues with, moving the well around quite a bit. And we've seen that even in the past, and we know why that is, right? But it's important that what's important for us is to give the customer a hole that's easy to complete, right? And it's on track, that's in the zone, and it's easy to complete. But, technically I'm looking to validate that, a bearing actually has the number of hours that we suspect. I'm looking to validate that we're consuming the right amount of power, that we're not, drawing too much power and draining our batteries too soon. Is that what kind of you're asking?
No, I mean, it's your show. You tell me.
Yeah. Well, so that's the big one is the customer acceptance. Did we do the job, right? Did we do what you expect? And if so, how can we make that better? Because that's it for us. Customers, everything for us. Giving them a solution that maybe is easier. I tell you, the really cool thing about this system is that we put all the bearings and all the things that we thought were wear items at the end of the tool. And that way, all you need is a breakout machine, break out the tool, pull out the mandrel, and then change all of the bearings in the field, in a motor shop. And we designed it that way. So being able to train our customers as well to do that is important. That makes our system a lot more scalable than us trying to do all that ourselves and to build that whole infrastructure ourselves.
So I know you went back and you said that you guys have done this complete research of the industry, talking about customer acceptance.
Mhm.
How has the reception been from some of the directional drillers out there as far as the tool's concerned?
I think in terms of performance, it's good. They like to see a tool like ours that has headroom, it has the ability to, that's easy to operate. I think, just I'll be right up front about this. It's not always in the directional company's best interest to pick up a new technology like a rotary steerable and to run it for a customer. And so I think early on we thought maybe that would be, that we could walk into a partnership with all the directional companies, and they would love what we're doing and they would push them, to the customers. But, if you really think about it, it's not necessarily in their best interest always, right?
Yeah.
To push new technology. And so what we really did is we retracted a little bit. We said, look, we don't want to put you guys in a bad situation. So what we'll do is we'll go talk to the operators, right? We'll go talk to the operators and we'll see if this technology makes sense. Does it make sense for the big picture of your well? And it turns out it does in a lot of cases. The features of it, the ability to turn, the vertical curve lateral one run, the high temperature aspects of the tool are appealing. And the serviceability of the tool and the cost is appealing to the operators. And so then the operator comes back to the directional company and says, this is what we've decided to run. And many times, most of the time, actually, we contract through the directional company. So, we don't want to put them in a bad situation. We know, guys, trust me, we know the track record with rotary steerables, and it's not easy, and, it's easy to leave things behind, and to mess up, and to get off course and to, have to, cause sidetracks and all that. We recognize that, and we don't want that. And that doesn't need to be, that responsibility, that risk doesn't need to be in the directional company.
It's funny. One of the guys that we had on the show before works with the insurance company, and so they insure BHAs. And his joke is, that he's the number one owner of rotary steerable tools in the world.
Yeah,
and he's like,
Yeah.
but you can't access any of them, right?
Yeah.
So,
Yeah, Mother Earth owns them sort of now. It's a
Yeah.
joint partnership.
at least on paper, they're all his. All right.
Yeah.
So we had a question here or a comment. What's that one?
Okay. Question.
What is your idea for services in Latin America? From Carmen.
We are absolutely open to Latin America. We've drilled a couple of wells, maybe a handful of wells in Mexico, and then and now we've actually got some others on the books right now. So we're absolutely open to Mexico. Mexico's great because, again, it's relatively, I say relatively, of course it depends. Now you're going to challenge me now that I say this, but it's relatively easy drilling, meaning benign drilling. We're not pushing every parameter to the nth degree every time we run. I mean, we're not trying to drill
record wells
12, 15 degrees, 100 at record speed, in 15,000 feet in 3 days or something. So that's nice. That's being a little easier on tools is a good thing. So we are absolutely open to that.
Yeah. You want to just take it for a stroll? Let's do that.
Yeah. Can we just do that? And like I said, none of the early wells you think, can we just kind of tip our toe in the water a little bit? Let's just do an easy run here and there, and maybe a small section. But it just turns out that the opportunities we were given were like, well, nobody else will work here, so at least we'll try you. We'll give you a shot.
It gives me the picture I'm imaging. The thing I'm picturing in mind is like, like at one of like these like sea fronts where like the waves are like crashing in on the big jagged spikes and stuff like that.
Yeah,
And it's like, here, you guys go out there and do this one. When you're like, can we just be in the kiddie pool
exactly.
on land with the lifeguard for 5 minutes?
Yeah, I mean, good news is we're all, we were up to it, right? And in some of those we did a really great job, but that's, you got to take it for what it's worth. You got to be able to stomach. I would say, people have asked me, so what do you recommend in running a company like this? What do you, what kind of skills do you need to do this? And I say, man, be comfortable with diversity. Be able to take failure. Be flexible. If something fails, if something doesn't work quite right, be able to flex and turn on a dime. And change that, improve it, and to be able to take the failure, because we had something. I mean, a lot of people that are engineers know about this, and it's called analysis paralysis, and that is where you study something so long that you want to get it perfect before you go test it, right? It's got to be perfect, and if you did that with one of these systems, you would
never.
10 years, to actually get it in the ground. So we
by
decided
then the market would completely have changed.
Yes,
just about.
Yeah. So I mean, getting comfortable with that, being able to find the customers that are willing to take some risk, to see that that the benefit in the end is greatly outweighs the risk, and that's where we are. I mean, we're much lower risk today.
I didn't get that.
Thank you, Siri. So we're much.
I'm asking the questions, Siri.
Yeah, we're a lot smaller risk than we were, 4 years ago when we talked last. We've proven the system. We've worked out pretty much all the bugs in the system, and
how does that
happy
feel
to
for
be there.
you? How does it feel for you to be able to say that right now?
Well, I don't know. It's the first time I've said it, I think, actually out loud. I think if I could rewind to 2019, and then I could jump to 2023, like in a time machine, I would feel great saying it. But now I've got like all this mileage and this worry and this, and this baggage, from the last 4 years of having to get through and keep the company alive and do all that. I'm like, well, thank God we're finally here. Thank God it's finally working. And it's a very proud, experience. I'm a proud papa to be where we are today.
Well, I had a great engineer I worked with that told me about, like, we're starting here, getting here. We got to just do that, right?
Yes.
Just a little incrementally.
But our line, it wasn't like a straight line. Yeah, we knew we had to get here, but what we didn't realize is, the shortest distance between 2 points is a straight line. Yeah, we thought we were going that way, and something pulled us this way, and then it went that way, and then it went that way. So the line's a lot longer than we thought it would be, but we're at that point, though. It doesn't matter. Doesn't matter how you get there, but we got there. We're there. We're getting there.
How does it feel for your team?
We have to remind them. We had an all hands. We have once a month, once every few weeks or so, we have an all hands meeting. And we just get people together. And with an all hands meeting, you got to make sure that you tell everybody there's no big announcements happening. Nobody worry. This is a regularly scheduled event. But we had this meeting yesterday, and we have to consciously remind folks about where we came from and where we are today, and I'll tell you why. Because they're so hard worker. They're such hard workers, and they're so focused. And they're so smart, and they're absolutely all focused on one plan and one and success and hitting TD in every well. That I don't think our folks look up that much. It's just part of their wiring. I hope they are proud. I hope they're very proud of what they've done, because it ain't everybody that can build one of these guys.
I could build one of these.
Okay, well, you can build one, but not everybody can. You can build one on your 3D printer.
Yeah.
In there.
I'm still happy to have the bit right there at the end. All right, so we got a couple more questions that have come in. John asks, what are your reliability statistics compared to other RSS technology?
Well, yeah, that's a really good question. They are not as high as Schlumberger and Baker, I'll say that. But we don't have a lot of track record either. So I will say that we have, we have a lot of, out of 40 wells, I would say in the exponential increase in productivity or in efficiency of drilling and the completion of those wells is, in the last 5 or 6 runs or so, is significantly better than it was early on. So we don't have enough, with 60,000 feet of drilling, we really don't have enough data to be able to compare. I would say that I was given a little bit of a guideline not long ago that if we drilled 2 wells and failed on the 3rd well, right? If we drilled 2 wells to TD and then we failed on the 3rd well, that would be at pretty much the standard of what they were dealing with right now from the big guys.
Wow.
And a lot of people don't hear that. They don't believe that. And it's, and depending on where you pick or cherry pick those numbers, they could be, they could be all over the map. But, I know that there's really good systems out there. Obviously, Schlumberger and Baker command the market there. But I think what we offer is a better alternative that can do the high dog leg. They can do the high temperature. It's not as expensive and has customer service. We're able to tailor our tools for people if they have special needs in their tools or in their wells, and to put dedicated teams on those rigs to make sure that they succeed. So yeah, I don't have those numbers on the top of my head, but they're improving. They're getting better, and every well that we drill, we've got some of the big guys now that are interested in us, and actually they're running us. I can't really say them either, but we're come talk to us, and we'll talk to you about that. But the fact that the big guys are starting to put some confidence in us and run them on their wells is a good indication for us.
So is that big guys on the service side or on the operator?
On the operator side.
Operator side.
Yeah.
All right.
Yeah.
Then John says, will future RSTs develop sufficient downhole intelligence for future demands, completion/production, so it can continue operating with mud poles or EM, or will the industry need to adopt hard wire pipe?
I don't know. What I do know is that we started with EM, and man, is that nice. It's like 10, 20 times faster than mud pulse. It's 2-way. In order to send commands, you don't have to get out of your chair and do anything. You just type it in and it goes. But as everybody knows, EM is very limited in its range. I'll tell you what, with the automation and what we're doing, we have chosen to go down a little bit of the machine learning path or the AI path, but very cautiously, right? And so our tool does make some decisions downhole, and it does. If it starts steering and it realizes that steering is not adequate, then it will jack up it has long-term memory and short-term memory. And it will change its short-term memory or its long-term memory depending on the performance, depending on if it's a long-term or short-term issue. And and we have other learning algorithms that are on the drawing board right now. I will say that I think that greatly enhances the ability for a system to operate semi-autonomously, which means that you don't have to go to the wired pipe. I know the pushback wired pipe is awesome, right? But it also means you have to replace a huge inventory of existing equipment, drill pipe around the world.
Yeah.
So
there's an additional premium cost to that.
Yes,
Which I've heard has come down quite a bit.
right.
But that's still single point failure.
Yeah.
Additional cost, existing legacy assets that
Yeah.
for all intents and purposes work just fine.
I will say that we have invested some in artificial intelligence, but we have invested more in natural intelligence. It's true. We have. And that's where we, that's how we use AI. And I think that it's going to be important because I don't know, you guys tell me, it's a trade-off. Do you want to spend to replace all your drill pipe, all your dumb iron, basically? By the way, going from dumb iron to smart iron or something that's wired, that where you can have a glitch or a connection issue, is also a factor that one must think about.
Yeah, it's a lot of balls to juggle there to figure out what's going to work best.
It just takes one link broken for it not to work, right? One link breaks, one wire breaks, whatever, and now you're not communicating. So, anyway.
Well, I know we've got somebody here in the comment section who probably wants to talk about it. I was going to go to the one just prior to that. So Duncan, who I know is working with Exact, says, John, we have acoustic telemetry, which works in completions installation, TCP, liner running, drilling data all the time, sends up data up and down, no need to change the drill string. So,
yeah.
If you had something like that, let me ask you this then. Mm-hmm. Whether it's acoustic or it's wired pipe, what would be the next step for y'all? Knowing that, it's not just a one-off, but like...
You mean if we could get the data rate up, say an order magnitude? Or
not
two?
Just up, but
okay.
Be able to have the two-way communication. How much of an impact would that have on the industry and for you guys and your tool?
I think it's huge. I mean, I think of it as, first off, data. Let's take that first. Data rate. And I mean, the more imaging that you can have, you think about it. I'm sorry, guys. We're drilling kind of like this. Actually, we got eyeballs in the back of us looking backwards. 20, 30, 50 feet, whatever it is, and that's just a crazy way to make real-time decisions and steer.
That's how I drive home.
Well, okay, yeah, so having that is really important. Having two-way communications, real time, that's a big deal, because that means that you can put all of your models, your Earth models. You can basically have a digital twin at the surface while you're drilling, and tie the two together. So, and the end goal is that you're staying in the zone more often, and that you're reducing your downtime. So we're not thinking about that stuff right now. We're focused on how do we use existing technology to do the most with that existing technology.
All right. So
I will say that I welcome that. If somebody's got a acoustic two-way telemetry sub or MWD, the good news is that we have this Drillcom thing that plugs into MWD. It's tensor compatible. It's also like RS-485 and what's the other one, CAN bus or whatever, and it can plug in to pretty much any communication system for communication back to the surface. We decided not to be the long haul communications, not to be the mud pulse or the EM. We would just be the short hop and let somebody else take that part of it.
Take this, now deliver.
Yeah.
Makes
Yeah.
sense. All right, so yeah, we did have one other question in there, Jeff, about how much time and money would it take to improve your kinetic RSS to 25 degrees C higher?
That's Robert Estes.
Oh,
Robert Estes. Hello, Mr. Estes. How are you? I would. So you're saying go from 170. Right now we're 175. So you're saying go from 175 to 200. It's a big number there, but it's electronics is the good news. We've designed the rest of the system and the rest of the tool so that we don't have any fast acting seals, which create their own heat. So we don't have any devices in our tool, with exception of some little motors that power the system, which are rated well over 200 C. They're actually rated to 225 C, I think. We don't have any other devices in the tool that are fast rotating and high friction, or that create their own heat. And we did that for a reason, because we knew that one day we would want to push this tool to a higher temperature, and those fast moving seals are that can be a problem. For those of you that have designed stuff like this, that can be an issue. So to go to 25 C to 200 C, I would actually punt that question to our head of technology, which is Gary Altoff, because he's actually got experience doing that at a very large company in his past. But I mean, I don't know. I think it's less than $1 million. It's probably greater than 100,000. Because to get to, that's the deal, and Robert hits it on the head.
You just $900,000 pigeonholed yourself there.
Yeah. I mean, he hits it on the head perfectly there, and that is that to go from 175 to 200 is a little bit of a quantum leap. It means that now you're buying silicon wafers. You're buying these entire can't remember what they call them. That's the wafers essentially, and you're placing those semiconductor circuits on a piece of silicon or other material, and you're actually building your own gigantic chips. And you do that so that you can get the heat away from them, and other reasons, but and so that thermal expansion isn't such a big problem. But yeah, I mean, that is something that we look at, because the hydrothermal wells, geothermal wells is a real focus for us only recently. I mean, that's something that we realized that we actually might be pretty suited for, because of the simplicity of the design. I mean, this is all, everything rotating here is all, there's no seals there, right? It's all mud lubricated. It's very similar to bearings in mud motors, mud lubricated motors, and even the seals that are here are very, very slow rotating seals. We've even designed our communication to be tolerant, our communication system and all of our connectors to be tolerant to that high temperature swing. So I don't think that answered your question, other than my $100,000 to $1 million, quote.
I mean, in oil field terms, that's a pretty small window.
Yeah. Yeah. It's not, I guess what I'm saying.
Not for my salary, that's a pretty huge window,
it's,
but like for oil field, costs and stuff, it's pretty tight window. All right, what's this one? Will you be at the SPWLA talking about it? What is Society? I don't know what that one is.
I don't know.
Anybody else?
Maybe one of our.
That's alphabet soup that I have not. I've probably seen it before. I just didn't
if it's
know.
Local, I'd be more than happy to, but I don't think I've been invited to.
Okay. Well, it's in. Click that one. So what did Brett say? You don't need wire and drill pipe to have wired drill pipe. Okay. I mean, yeah. So there's the acoustic or
To have a wired drill. Who is that? Is that
Brett Van.
oh, that's Brett. Hey, Brett. Yeah. What, like wireline? I don't know.
I don't know either. I'm not. I'm not. Oh, he said that's the Society of Society of Professional Well Log Analysts. Oh, I never knew that.
If it's local, I'll be more than happy to attend.
Yeah.
Yeah.
You're all for speaking engagements.
Yeah.
You'll come out here a second time.
No, I'm going to put that on George. He's a much better speaker than I am.
I did mention in the last one that we should have had George on here. So he says salty mud.
Salty mud. Are we good in, like, you're talking like water-based mud? Oh,
Well, no,
salty
no.
mud. That's Brett.
The wired pipe.
Okay.
He's dropping us little hints, and
Okay.
we've got to figure it out. I don't know. I know
All
that
right, Brett. He's thrown down the gauntlet.
Exxon has a patent for I shouldn't say high-speed telemetry, but another form of telemetry where they ionize the mud.
Oh, okay.
And then use that as a way to be able to communicate.
That sounds really cool.
I have to remind the
I'll be there
audience of a funny conversation that we had about talking about how to be able to do different types of MWD telemetry, and yours was like free radicals or neutrinos.
Oh, neutrinos. Yeah, yeah.
So
unfortunately, it's hard to stop those things. You know, you need a salt dome and a whole bunch of heavy water or something. Yeah.
Yeah, that was a fun conversation. We were just talking about like different ways to be able to send
So
signals.
look, I'm never going to do anything with this, and probably nobody's ever going to do anything with it. But we did have an idea many years ago, and that was we used real quick. We used these red grease bearings, and it was we had a name for it, and it was the something red grease, the explicative red grease, because it would get everywhere. I'm sure if you've used it, you've been in an oil field, you've had the red grease before, and it gets here and there, and it's everywhere. We had red grease in our bearings early on, and through the entire well, it was just the bearings packed in this red grease. The entire well, you could see red grease coming up through the shakers, right? There was little bits of red grease coming up through the shakers. And so we thought this idea, well, maybe if we had like smoke signals, we could send out some red grease or some green grease if everything if everything was good in the mud, send the green grease in the mud, and then if things go bad, you could send the red grease or maybe yellow grease, or different colored greases could mean different things. Anyway, yeah. Sorry, guys, that's not. There you go. Take it and run with it.
There we go. Red grease, MWD telemetry. All right. We've got a whole bunch of people telling us what the SPWLA stands for.
Oh, and this is also from Robert, just to confuse you guys with all the acronyms you already have.
New name for SPWLA is Society of Petrophysicists and Well Log Analysts. Oh, the new name. Okay. Surprised they even keep the petro part. Not everything's been changed to Society of Green Engineers.
Oh, yeah. Hey, man, sustainability is good. Like I said, geothermal, man, it's the way. It's the way. We want to be there when it happens, but in the meantime, we're going to be, drilling some wells to get natural gas out of the ground and oil or whatever they want.
Yeah. Really, it's a tool to make holes in the ground. It's not a tool to get oil out of the ground. It's just I'm into making cylindrical holes below surface.
That's right. In very odd directions.
Yes.
Very unique directions. I just can't believe the wells that we're doing these days. I mean, I know to most, directional guys out there is nothing but these, for me, the back build and the, what do they call it? Turnizonal,
Oh, yeah,
wells where you're
the
turning and you're
U-turn
building,
wells.
you're turning and you're building at the same time. That's what we're doing now.
Well, not
That's
just
the stuff that we're
horizontals.
doing.
There's the ones you go all the way out and then
Oh,
you
and
get
then
to the
turn
end of-
around.
and then at the
Mhm.
end of the lateral and come back. And then somebody posted the other day on LinkedIn about drilling a W-shaped well.
No way.
Yeah, I'd be very loosely. I mean, it's not how I would tell my son Weston to write his W's, but yeah, it kind of had
Mhm.
that little bit of that path to it. So.
Well, whatever works, and there are a lot of people looking at some really interesting things, and ways. And if you need to put a strange-shaped hole in the ground, curvy hole in the ground, let me know, because that's what we do. That's
Curvy to a straight hole.
Well, hopefully, yeah, curvy. Yeah, hopefully it doesn't. When I say curvy, I don't mean like.
Let's just start drilling these.
Yeah. Yeah. Vertical curve lateral, man. That's where it's at. That's where it's at for us. Do that all in one run, and it's pretty cool.
So, just because you've been an amazing mentor to me and have left me with so many great nuggets of knowledge, impart on the audience, right? For anybody else that's thinking about their entrepreneurial journey, what is some key advice that you would give? Not just for designing tools and being in oil field, but I know you've done stuff in aerospace and engineering and even stuff with satellites and whatnot.
Mm-hmm. So I think know the customer. I mean, I don't know. I'm a tech company guy, right? So everything that I'm doing, and there are lots of other ways to make money, to be an entrepreneur.
There's a lot easier ways to make
Oh my
money
God.
than
Yeah.
commercials.
Yeah. Like I said, when you get to the point where you're thinking, I didn't think it was going to be this hard, you need all the other people pulling you along to say, it's okay, come on, we can make it. Okay, so that's part of it. The first part is to know the product. If it's a technology, know the product and really be compelled. I mean, literally compelled that this is the best thing since sliced bread. Right? This is going to change the world. It's going to reinvent the way we do drilling, and believe in it. And then go find the people, right, that will believe in it with you. Put the team together of the people that are absolutely motivated and inspired, and because there will be a time, and all my coworkers can tell you this, there will be a time where even you lose faith and you think, what am I doing? I can't believe I thought that. It was the imposter syndrome, right? I can't believe I ever thought that I could do this. Why did I think that I could build another rotary steerable? Are we crazy? And that's when that's when the people that you find that you put together as a team, that's when, and that you're blessed to be part of your team, that's when they can pull you along. So that's a big one, right? Find your teammates, find your people. For me, just from the early start, it was George. George said, you can do this. You figured it out. This particular tool, he said, you actually figured it out. You figured out how to make it way better than what we had before, and better than what's on the market. And to have that kind of belief in you, and have a really good wife like mine, also one that supports you, even though you're running into this black void, this dark, bottomless pit, black void. Have somebody that.
But obviously, as we
really
learned
supports
through
you.
the shows, sometimes being in the black void is where you need to be.
That's exactly right. You can't get out. You have to, so the other thing is those people have to be comfortable being out of their comfort zone, because, or if you, like for me, there's a big area that's not my comfort zone. I hate being there. I don't draw energy from that. It sucks energy from me. And I think, but you know what? I have to do it. And that's the other thing. Get comfortable with that. get
So
comfortable with
sales?
having to do, oh, it's sales, it's finances, it's going and, raising money, it's doing all the things that are required to run a company like that. And I'm an engineer, so it's not my wheelhouse. But find those people that can fill that area that's not your comfort zone. I know I can tell Gary to go talk to those guys. It's a little bit confrontational, but I don't want to deal with it, or I can tell George to go, talk to the operators, or talk to the customer about something that maybe is a little uncomfortable for me. And those guys, they don't have a problem with that, and they'll go do it and they pull me along. So I think that's the biggest one. You get comfortable with doing things that are uncomfortable, and that's like a muscle, right? I mean, it's easy to sit every day, and I tell you where I'd rather be. I'd rather be doing analysis, not with you, not today,
Yeah.
right? But rather than doing
this show, God,
rather than doing sales, and rather than doing all of the financial kind of stuff that we have to do, which is really important. I'd rather be sitting in front of a computer doing analysis and design. I mean, that's where I'm at. And fortunately, I had a good mentor early in my life, a guy named Max Faget, who was they call the father of Apollo. I got to work for Max for 5 or 6 years. And Max was he was the head of engineering during Mercury, Gemini, and Apollo. And yet he still, at 80 years old or 75 years old, whatever he was, he still found time to stand at his board and to do calculations and to do the science, right? To do the science and the math and the engineering. And that's because it gave him energy, and that gives me energy. So that's the thing I would say. Find small times. If you're starting a company, you're going to be overwhelmed with raising money and doing business plans and charting the course of your company and all of that. If that brings you energy, great, right? If it doesn't, make sure you find time to get back to those things that do bring you energy, right? Not just the things all day long that consume energy. But like I said before, that's a muscle, right? Being able to jump back and forth between uncomfortable things and comfortable things. You may hate to do that, and when you're starting a new company, you're, oh my God, I'm an engineer. I've got this idea, and I don't want to have to go talk to these people, and I hate doing this, and I don't like doing that. But the more that you do it, the more that you'll be comfortable with doing that from time to time, which you have to do. So,
all right. Well, do we have
We have another new question.
any idea about R&D people are in? Wait, any idea about where R&D people are in terms of MWD temperature limits? I read somewhere a couple of months ago they were aiming for 300 degrees C. So far, the limit is still well below 200 degrees C, right?
Don't know. I know that only the big guys that I know of, have a 200.
Halliburton and
C.
Weatherford both have a high temperature tool. Weatherford, I think, is a little bit higher than Halliburton's. There's a lot of 185C MWD tools on the market right now. There's people talking about being able to go to 200 degrees C, but I think that's just talk. I mean, from my perspective,
what are the highest batteries I've seen are about 185.
Yeah,
maybe 200. I don't know.
Yeah, I don't know about any 200. Yeah, even batteries, I don't know.
I guess you'd have to be generating. There's some temperature level where you've got to generate your power because you can't.
Eric says for geothermal development mainly. Yeah. I mean, there's certain developments that are taking place there. I would say this for anybody who says that they're shooting for a 300 degrees C MWD tool. That tool is of very limited capacity. It's not the same thing that we're running.
Aren't you getting up to like solder melting solder temperatures at that?
I wouldn't know. I just know that
600
like,
something Fahrenheit.
you know,
I
I
mean,
mean, you
maybe
could probably just, I mean, you know, maybe not measurement while drilling, but a survey tool, you could still just do like a paper punch or something. You
Mhm.
know, it's not going to send it up in real time, but you could probably create a fairly simple mechanical system to be able to, you know, single shot your way through it, you know,
Yeah.
but to be able to send up in real time and
I think the key is though is you have to make sure that the mechanisms, not just the electronic. It's not always the electronics, right? Make sure that the mechanisms can withstand those kinds of temperature swings as well.
yeah.
That's the big one. That's the one that's tough.
Yeah, maybe I can get Manoj to be able to come on. I've actually had this conversation with him the other day, and that's why I'm trying not to say too much because he's much more of an expert on it than I am. And he's a way better storyteller when it comes to that stuff.
There's Bob Fay from Excel saying that 200C is the limit for batteries. I've been
There we
beating,
go.
I've
Bob Fay's in
been
here.
beating Bob up for years about having, you know, high temperature downhole rechargeable lithium batteries, and he keeps denying me, man. He's like, no, you don't understand, Jeff. You're trying to violate physics, or whatever the reason is, you know. But yeah, so that's a limit.
Violate physics all day. Let's go for it.
Mm-hmm.
Then Brett said, fuel cells love 200 degrees C. Really?
Yeah. So Brett's thinking outside the box, man. There you go, Brett. That's good. That's what you got to do. Actually,
we just need to get Brett to come on the show.
You should, yeah. You know, going to 300, you got to tear it all down first. That is first principles, and we did do that with this guy, right? Before, we didn't say let's just knock off some other thing, let's take some other patent and, you know, do that, because we knew that, you know, that probably wasn't the ideal thing. And so, you know, we started at basic principles, and that's what you got to do with the 200 plus 200 to 300C. You got to sort of knock it all down and say, let's start with something new, and let's rethink how we generate power. Like Brett says, fuel cell.
I mean, or at that high of temperature, you could probably just convert heat to this.
Yeah, you gotta if you have a thermal
down there.
gradient. Yeah, if you can create a temperature gradient, then you can use thermoelectrics all day. I mean, they're not exactly super. They don't like vibration, but I use those in space, man. That was my first project. Was a refrigerator in space. Yeah, look it up. It's called
We're an hour and a half
C
into the
rim.
show, and you're going to tell me, you're going to drop this bomb on me now that your first project was a refrigerator in space?
Yeah, we built like 13 of them. They flew on the shuttle, and they flew on I mean, that was my ticket to some real fun times. I mean, because it was this refrigerator that was, it was always full of, and it was, University of Alabama, Birmingham was really the sponsor. Those were the materials, and not materials, but protein crystal experts, right? This is where you can grow a crystal so big in 0G that you can shoot X-rays at it, get the scatter, and actually reconstruct the geometric entity, right, of the molecule. And I'm really talking way.
Word you just said.
So what it allows you to do is it allows you to design. At the time, this was the big deal, to design designer drugs, essentially, that could, if I basically grow a protein that's associated with the virus AIDS, or the AIDS virus or whatever, then I could see what it actually looks like, the structure of it, right? How it would be formed. And then I could design a drug that would come and latch and fill that spot. I'm way out of my field here, but we designed the hardware that could ramp up the temperature and ramp it down at very close tolerances. But you can't carry like compressors with Freon on the shuttle. You know, that's kind of a bad thing if the Freon leaks. So these little refrigerators use thermoelectrics.
You didn't want to poison the
no, it's a bad thing.
Or kill the astronauts.
That's a bad thing. So the reason why it was a really cool job, even though I was designing refrigerators, was I thought, man, aerospace degree, why am I doing refrigerators? But the cool thing about it was always a late load because it was a life sciences experiment. And so it got to get put on the shuttle last, right? And so there were times where I had to go to Kennedy Space Center, drive, a gazillion miles from Houston to Kennedy with this payload in our truck, in our van, and be part of the integration and actually go to the shuttle and integrate it and install it in the shuttle when the damn shuttle's being, fueled. That's not a lot of people haven't been there, but it makes it real, man. When you're passing guard shack after guard shack after guard shack to get to the launch pad. Anyway, so that was there you go, thermoelectric.
So what was in the refrigerator?
The protein crystals, the solutions that were growing protein crystals. And so they would.
So they were growing those in there.
Yeah. Think of it this way.
There.
Well, okay, that's a good question. How did we size that? That is actually a trivia question amongst those folks. Is how did we size that locker location? And it was actually sized from a 12-pack. The volume that would go in there was a 12-pack of beer. It's true. Yeah. Okay, so
a refrigerator that would grow very large protein crystals.
Yeah, imagine you have this mason jar, right? It was a little more complicated than mason jar, but imagine you got a mason jar. Yeah, and you mix up this solution and you heat it up, right? You get it hot and you put it on the shuttle. The shuttle goes on orbit, it gets into 0G, and then automatically it starts cooling it down. And as it cools it down, the crystals start to precipitate. They grow. So now you have these big, gigantic crystals that have grown, and then they can bring those back to Earth and study them. This is an oil field show, right?
Yeah, but you told me you designed refrigerators in the space shuttle.
Yeah.
We got to know about this stuff. All right.
Yeah.
We'll
talk more about that.
Yeah, we'll just stop there. All right, guys. Love to hear about radiators in space, probably for another show.
Mm-hmm.
David, I know where one of those 200 C the Velo Mags is. Oh, okay, cool. High temp MWD components have been around for years. Develoco had a 200 C magnetometer on their catalog in 1988, but the asterisk says 100 hours max. Well, I mean,
yeah, that's the big thing, right?
This is the great thing about having a community to be able to jump in and tell us about some of this. Long-term operating expectations for high-temp tools have increased dramatically in the past few decades. Yes.
Yeah, that's right. In fact, we can thank the automotive industry. When we started in 1997 with little RST, some of you guys will laugh if you're electrical guys. We used an HC11 processor, and I think we stepped that up to an HC12 processor. That's a Motorola processor, I think. And the HC11, you cannot change the code. You burn the code on the chip, and then you solder it onto the board. And so if you want to change the software, you had to remove the chip and trash it, put a new one in with the new code. That's what we started with. And it had, I think, 128K of memory. We got gigs now, but it had 128.
That's a rough development cycle.
Well, that's what they knew what to do, and
those
were pretty rugged. Those are
makes
durable.
You a lot stronger and making sure that when you burn
incredibly efficient. That's right. Yeah. And the beauty of the HC12 was that you could actually program it from the side. That was, anyway, Brian Gonsolin helped us design that piece. Thank you, Brian. That was many years ago.
All right, guys. Well, thank you guys so much for tuning in. We do appreciate it. It's been awesome having Jeff here on the show again for a second time. Before I forget, we got to do a little giveaway. So we'll just throw that up on there. And then we've had 40 entries so far. So we'll click the draw button. And then let's see who's the winner for this week. Giving away a drill bit, hat, and branded ice cubes. Ari! Ari wins. He's all the way out there in Dubai. I think it's second time winning, but hey, man, this is what happens. You tune into the show, you can win a second time. I think we've got to send those. We've already had issues trying to send them over to him overseas, so we'll get that figured out. Ari, shoot me a message on LinkedIn and make sure that we get that handled for you. The first MWD tool in the Baker line.
Hang on.
Everybody's commenting all this.
They're clicking at the same time I'm clicking.
Oh, there we go.
All right.
The first MWD tool in the Baker line was the Canadian group. We only had 32 bytes of RAM.
32 bytes. Awesome. Man, that is efficient programming.
What do you do with that? Oh, MWD tools have come so far. So far. Well, like I said, thank you guys all so much for tuning in. We really do appreciate it. Had an absolutely amazing show today. Be back with us again next week. I'm not going to say who the guest is just yet because I think we're still waiting on him to get approval to be on the show. Mr. Lang, if you can, please. If y'all can please approve him to be on the show. Yeah, if you guys want to know more about the Kinetic Upstream and the Contour tool, be sure to reach out and get in touch with Jeff. Follow him on LinkedIn. Follow me on LinkedIn if you haven't already. Trying to think. You guys, everybody have a great weekend. And as always, know your industry.